Dengue fever is a serious health concern affecting millions worldwide. It is a mosquito-borne viral infection found in tropical and subtropical regions. Dengue represents a significant global health burden with an estimated 400 million infections annually. The World Health Organization estimates that half of the world's population is at risk. The incidence of dengue has grown dramatically in recent decades. Climate change impacts mosquito breeding patterns, increasing dengue prevalence. By reducing mosquito breeding sites and protecting ourselves, we can combat this global threat. The dengue virus belongs to the flavivirus genus and is transmitted to humans through the bite of infected Aedes mosquitoes. There are 4 distinct serotypes of the dengue virus: DenV1, DenV2, DenV3, and DenV4. Infection with one serotype provides lifelong immunity to that particular serotype. However, subsequent infection with a different serotype can increase the risk of developing severe dengue. This phenomenon, known as antibody-dependent enhancement, makes dengue a complex and challenging disease to manage. The virus primarily infects and replicates in the white blood cells of the human body. These cells, responsible for fighting off infection, become factories for viral replication, releasing more virus particles into the bloodstream. This process triggers an immune response, leading to the various symptoms associated with dengue fever. Understanding the different serotypes and the potential for antibody-dependent enhancement is crucial for developing effective vaccines and treatment strategies for dengue. Currently, there is no specific antiviral treatment for dengue fever, and management focuses on supportive care to alleviate symptoms and prevent complications. Dengue fever typically presents with a sudden onset of high fever, severe headache, muscle and joint pain, and a characteristic skin rash. Other symptoms include nausea, vomiting, and pain behind the eyes. A small percentage may develop severe dengue, a life-threatening complication. Severe dengue requires immediate hospitalization and intensive care. Early recognition and prompt medical attention are essential. Seek medical advice if you experience any symptoms, especially in dengue endemic areas. The primary vector for dengue virus transmission is the Aedes aegypti mosquito. This mosquito species is easily recognizable by its distinctive black and white stripes. Aedes albopictus, also known as the Asian tiger mosquito, is another species capable of transmitting the virus. Aedes mosquitoes thrive in urban environments and prefer to breed in stagnant water collections found in and around homes. These breeding sites can include discarded tires, flower pots, buckets, and even small containers holding water. Female Aedes mosquitoes require a blood meal to develop their eggs. When an infected mosquito bites a human, the virus enters the bloodstream and begins to replicate. After an incubation period of 4 to 10 days, the infected individual can transmit the virus to other mosquitoes through further bites. Understanding the breeding habits and preferred habitats of Aedes mosquitoes is crucial for implementing effective vector control measures. By eliminating breeding sites and reducing mosquito populations, we can significantly reduce the risk of dengue transmission. Section 5. Breaking the chain of transmission. Preventing dengue fever relies heavily on mosquito control and personal protection measures. Eliminating mosquito breeding sites is paramount in reducing mosquito populations. Regularly inspect your surroundings and remove any standing water accumulations. Clean and scrub containers that collect water such as flower vases and pet water dishes at least once a week. Dispose of used tires properly or store them in a dry, covered area. Use mosquito nets while sleeping, especially in areas with high mosquito density. Wear long-sleeved clothing and pants when outdoors, particularly during peak mosquito biting hours, which are typically early morning and late afternoon. Apply mosquito repellents containing DEET, picaridin or IR3535 to exposed skin. Follow product instructions carefully. Community-based efforts are essential for effective dengue control. Participate in community cleanup campaigns to eliminate mosquito breeding sites. Educate your neighbors about dengue prevention strategies. By working together, we can create a safer environment and reduce the burden of this preventable disease. Section 6. Managing dengue, treatment and care. Currently, there is no specific antiviral therapy for dengue fever. Treatment primarily focuses on managing symptoms and providing supportive care. Rest is crucial, allowing the body to fight off the infection. Over-the-counter pain relievers like paracetamol can help reduce fever and alleviate pain. Avoid aspirin or ibuprofen as they can increase the risk of bleeding in individuals with dengue. Stay hydrated by drinking plenty of fluids such as water, oral rehydration solutions or fruit juices. Dehydration can worsen symptoms and lead to complications. Severe dengue often requires hospitalization. Intravenous fluids and electrolytes are administered to maintain hydration and electrolyte balance. Close monitoring of vital signs, blood pressure, and urine output is essential. Blood transfusions may be necessary in cases of severe bleeding. Early recognition of warning signs of severe dengue is crucial. Seek immediate medical attention if you experience intense abdominal pain, persistent vomiting, bleeding gums, rapid breathing, or a drop in blood pressure. Timely intervention can be life-saving. Section 7. Dengue in a changing world. The global burden of dengue is expected to rise in the coming years due to a confluence of factors. Climate change, with its impact on temperature and rainfall patterns, is creating more favorable conditions for Aedes mosquito breeding and survival. Rapid urbanization, particularly in developing countries, often leads to inadequate water management and sanitation systems, creating ideal breeding grounds for mosquitoes. Increased international travel and trade facilitate the spread of the virus to new areas. The emergence of insecticide resistance in mosquito populations poses a significant challenge to vector control efforts. Novel approaches, such as genetically modified mosquitoes and Wolbachia-infected mosquitoes, are being explored to combat dengue transmission. Addressing the complex interplay of these factors requires a multi-pronged approach involving public health interventions, environmental management, and technological innovations. International collaboration and sharing of best practices are crucial in our fight against dengue. Section 8. The importance of community action. Combating dengue requires a collective effort. Community engagement is essential in raising awareness about the disease, promoting preventive measures, and supporting those affected. Educate yourself and others in your community about dengue, its transmission, and how to prevent it. Organize neighborhood cleanup campaigns to eliminate mosquito breeding sites. Encourage responsible waste disposal practices. Share information about dengue through community meetings, flyers, and social media platforms. Support local health authorities in their dengue control programs. Report any suspected dengue cases to health officials promptly. Early detection and reporting are crucial for implementing timely control measures and preventing further spread. By working together as a community, we can create a united front against dengue. Section 9. Research and innovation. The fight against dengue. Scientists and researchers worldwide are continuously working to develop effective vaccines and antiviral treatments for dengue. Significant progress has been made in recent years with the development of the first dengue vaccine, Dengue, approved for use in several countries. However, challenges remain, including the need for vaccines that provide long-lasting immunity against all 4 dengue serotypes and are safe and effective for all age groups. Researchers are also exploring novel approaches, such as monoclonal antibodies and antiviral drugs, to treat dengue infection. Genetic modification of mosquitoes to make them resistant to dengue virus transmission is another promising avenue of research. Wolbachia, a bacterium that naturally infects some mosquito species, has shown potential in reducing dengue transmission. Continued investment in research and innovation is crucial for developing and implementing effective tools to control dengue and alleviate its global burden. Section 10. A future free from dengue, our shared responsibility. Dengue fever poses a significant threat to global health, but it is a preventable disease. By understanding the virus, its transmission cycle, and the importance of prevention, we can collectively work towards a future free from dengue. Individually, we can take steps to protect ourselves from mosquito bites and eliminate mosquito breeding sites around our homes. Communities can come together to implement comprehensive dengue control programs, raise awareness, and support those affected. Governments and health authorities have a crucial role in providing resources, implementing effective policies, and supporting research and innovation. By working together across borders and sectors, we can make a tangible difference in the fight against dengue. Let us all pledge to do our part in preventing dengue and creating a healthier and safer world for ourselves and future generations.